Okay, we're going to talk very quickly about an important topic, which is vectors, basis vectors, and vector spaces. This will become very important as we move forward with our videos. Vectors are at the core of all physics theories, and so we need to look at them in detail. It's clear so far that we have been referencing any point in the two-dimensional plane as a set of Cartesian coordinates x, y. Okay? They can be written with brackets and a comma, or they can be written in vector form as a column vector x, y. That's some amount x along the x-axis and some amount y up the y-axis. Okay, that's our vector x, y. But you can break that vector up, you can decompose it into simpler vectors. You can do it like this. xy is the same thing as x times the vector 1, 0 plus y times the vector 0, 1. Okay, if you multiply these numbers and add, you'll get the same thing back, right? These numbers here are scalars, and this is really the origin of where this word comes from in linear algebra. Scalar is just a regular number. It has no direction, only magnitude. Okay, so the idea here is that any point x, y in the 2D plane is some linear combination of these two vectors scaled. Okay? So these two vectors have an important name, okay? It's called I hat and j hat. These are the unit basis vectors in the Cartesian coordinate system, or an orthogonal coordinate system. Okay? What this means is that I hat is one unit along the x-axis and j hat is one unit along the y-axis. And absolutely any vector on the entire 2D plane can be written in terms of these two vectors, some linear combination of these two vectors. So all vectors are accessible with these alone. Okay? That's why they're called basis vectors. Okay, basis vectors means any two vectors that can span, is the word, span the entire plane that we're talking about. They're called unit vectors because they're of length 1. Okay? You can describe all vectors in the plane in terms of any two basis vectors. They don't necessarily have to be orthogonal or unit vectors. So for example, if you take this system here, you have the vectors u and v. We can describe the position of this point here in terms of the vectors u and v. Maybe it's 2u plus 2v, okay, as an example. These are not unit vectors and they're not perpendicular, but nevertheless we're able to describe any point in the 2D plane as some combination of these. Okay. The reason we choose these I hat and j hat is because these are in the orthogonal coordinate system and they're of unit length, so it makes things much easier. But the whole idea of vectors gives rise to the idea of a vector space. Okay, this is a collection of objects which we call vectors, which can be added together and multiplied by scalars. So basically, vector algebra involves only adding vectors and scaling them, okay, plus a certain number of axioms like commutativity, associativity, the existence of an inverse, the existence of an identity element, and so on. Okay, a vector space is basically the span of the entire plane of vectors built up from the basis vectors. Okay, and as I say, any two basis vectors can be chosen. Okay, that's not quite true. Okay, so for example, if you wanted to describe the two-dimensional plane, the trivial example is you couldn't use zero vectors. So you couldn't use u is 0i plus 0j, for example, the zero vector. You couldn't use these two, okay, to form a basis because they can't span anything. They're of zero magnitude, zero direction. Okay, you could also, if you think about it, two vectors that point in the same direction. Okay, you can never describe this point here based on these two vectors because they both are in the same line. Okay, so you need two vectors in order to form a basis. You need two vectors which at least don't point in the same direction. Then with some combination, some linear combination of these, you can get to any point in the plane. Okay? So if, for example, you do have two basis vectors in the same line, these vectors will be linearly dependent one on the other, one upon the other. They're not independent of one another. Okay? So this will become a problem. Okay, it's important to understand these concepts, and we'll be delving into it in a little more detail in the next video.